Good morning, everybody. Welcome to ninth grade science. My name is Mr. Boder. Here's what we're doing today. As you can see, we are doing this activity called Change You Can Believe In. The guiding question here that we're looking at is how is the behavior of atoms and molecules? So we're going to zoom in on those atoms and molecules. How is that different when we go through a physical change versus a chemical change? I know you did some of this stuff in 8th grade and you probably have decent understandings of this, but to be honest, we're going to get a more detailed, accurate understanding at a 9th grade level. What I want to do first is elicit your background knowledge, get what you know out and sort of everything you can think of. We're going to take a minute here and think about what the difference between those terms, physical change and chemical change, might be in the world of chemistry. So no right or wrong answers at this point, just thinking about what you already know. Write down how you would describe those two terms, physical change, chemical change. Go ahead, take 2 minutes. It's just going to be 2-minute quiet write time. Go pause the video right now, and at the end of those 2 minutes, I'll meet you right back here. Okay, cool. I bet you've got lots of answers that are around the right answer. Maybe could use a little bit of fine tuning, which is exactly what I expect 9th graders to have. It's going to be optional today, up to the guest teacher whether or not we share with our partners. I'd like you to make that decision based on time. If you are going to go with the share with your partners, that's great. Go ahead and pause the video and do that now. If time is not going to allow that today, we'll move right on to number 3 here. So in the space provided below, we're going to sketch how you believe solids, liquids, and gases appear on the atomic level. We're going to use a small little circle to represent an atom, and next to it we'll talk about what's happening in each drawing. Because remember, we're wondering how is the behavior of atoms and molecules different in those physical changes versus chemical changes, looking at what the molecules are doing. So if we think of a solid here, we recall back from like 7th grade, 8th grade, what are the atoms in a solid going to look like? Are they all loosey-goosey? Are they like gridded up, stacked on each other? And of course, they're pretty stacked on each other. I'd like you to draw them about the size that I draw them here. Don't draw them too small, don't draw them too big. You'll notice how they don't follow the edge of this is like a view screen. It's not, I guess, a container in this case. And I have them kind of like showing like I'm zoomed in on some really crazy high-powered microscope. The molecules here, or the atoms, are all gridded on top of each other, kind of touching each other. They will be vibrating and moving around because, as the kinetic theory of matter tells us, all matter is in motion. But they're locked in place, so they're vibrating just within their little spots. That's what a solid's going to be doing. If we go over to a liquid, we know that, well, what should the molecules do? Do they pack in tighter? Do they shrink, expand? Do they sort of spread out a little bit? They spread way out. What do they do? And of course, what they do is they spread out a little bit, but they're still near each other and they're still attracted to each other. So we'll try to draw that by spacing them out just a little bit. The molecule size should not change, like the atoms themselves don't get bigger and smaller. And it's always so hard. I try to draw these without like making a grid or a pattern. You try to be like random with where you place them. It's always a little bit tough. And there we go. There's sort of a representation of what the atoms in a liquid might look like. And then we come over to a gas. And of course, we recall that the atoms in a gas are going to be way spread out from each other. So spread out, in fact, that if I was this zoomed in, if I was so zoomed in that an atom was this big, in a gas, a sample of gas, I might expect to see like 2 atoms of gas is all. And then I guess if you want, you could draw them. They're like bouncing around the room and the container flying around. So there's your gas molecules, your liquid, your solid. Now let's look at number 3 also. 3. In the diagram similar to the drawings above, how do you think you should approximately show 2 atoms that are bonded to each other? In the space provided below, we will sketch how we think O2 gas will look like at the atomic level. Remember that O2 means 2 oxygen atoms are bonded together to form an oxygen molecule. And that's going to look similar to this gas, except we're going to draw and show the bonds by just showing the 2 molecules, or the 2 atoms of oxygen in the 1 molecule that they form stuck together like that. And again, because it's a gas, they're so spread out, they're just bouncing around. Once you got caught up with your drawings here, I want you to go ahead and flip over to the 2nd page and we'll show you what you're going to be working with. This is a really, really cool activity. It's going to actually, through these cards, You'll come up with your own correct definition. It'll be based on your discussion with your lab group going through these cards and the decisions you make. You're going to write concise, which is short and to the point and accurate, one-sentence descriptions for a physical change and a chemical change. My pro tip, do this one first. If you can write your chemical change description, you can then usually base your physical change off of it. This one's a little easier to write after this activity. So here you go. Your background. You will be provided 9 changes in chemistry cards. Here's what they look like. You're going to get 9 of these cards by your guest teacher. Each card represents a change that a substance or substances undergoes. I'm going to try to read here while I look at the cards. The circles on the left, so these circles here represent the atoms or molecules before they undergo the change, and the circles on the right represent the atoms or molecules after they undergo the change. We have to remember each circle is just a snapshot of a situation, so the number of particles between the before and the after may not be the same. And then if you see any particles that have like a plus or a minus on them, that means they are an ion, and if we recall, an ion is just a charged atom. So here's your procedure. Your task will be to categorize each of these changes as either physical change or chemical change, and then you'll decide, based on your observations of the changes, what indicates a physical change has occurred and what indicates a chemical change has occurred. I want you to record your ideas on this table as you go. Here's the best way to do this. You'll start at your table and you'll discuss each card as a group. Don't just pass them out to individuals, but discuss as a group. So we might start with A. The first thing it's asking you to do is to describe the change. So I would take a look and I'd go, okay, before, what is this? Is that solid, liquid, or gas? Well, that looks like liquid, right? They're kind of spread out. They're not crazy spread out. And then down here, solid, liquid, gas. Yep, that's also liquid. And then my arrows are going to indicate the change. I'm seeing that these come together, so I might say in my description of change, 2 liquids combine to form, and then what is this? Solid, liquid, or gas? That's also a liquid, right? See the spacing of the molecules? There's not like a set grid. They're also not crazy far apart. So my description here might be 2 solids combined to form, or 2 liquids combine to form a liquid. And then you'll decide with your group what type of change is that. Is it physical, chemical? And then explain why you think so. As I mentioned, these arrows will help you kind of figure out what's going on here. Here's another one, a little harder one from later. First off, this is a tricky one. Are you seeing the blue diamonds, or are the atoms represented by the silver circles? Do you see the silver circle now? Do you see all the silver circles? That's tricky for some folks' eyes, and that's okay. If you need to draw a couple circles on yours to help you see the atoms, you're welcome to do that. So what is this? Solid, liquid, or gas? It's definitely solid, right? Very gridded. And this is solid. Yeah, you probably recognize. And then, here you go. Here's a gas. This is also liquid. But let's look at these arrows. What's happening? We get these 2 substances. I think the arrows mean they come together and then form 2 different things. So I guess they're mixed together, and then we end up with that coming out of that change. So take a look at those arrows. They'll help you, and then you'll describe, for a solid mixes with a liquid and produces maybe a gas and a liquid. Again, you'll decide with your group. Do these together as your group. You want to look real closely. Big hints are to look at the shapes of the molecules as you go forward to back. Call the guest teacher over. They do have the answer key if you get stuck on any. You want to do this without knowing what the atoms represent. These are real reactions, but I want you to try and do it without even knowing what material this is or what material that is. You'll probably recognize some of them, but try to do it without, and just think about how the molecules are moving. Once you've got good answers, I want you to check your definitions with your instructor. If you've got it right on, then you're going to move on to the next page, and where you will get the actual atom key, and you'll go through, and using the atom key, you'll match up these cards to the actual real-world scenarios. Once you get that finished, if you finish before the time, talk to your instructor. You're going to get the next activity, and you'll be moving on towards an extension activity. It's pretty cool coming down the line here. If you have any questions, your guest teacher is here and has the answer key. Thanks so much for listening, and I will see you next week. Bye.